Combinational circuits. In digital systems, there are two types of circuits are used: combinational logic circuits and sequential logic circuits. In this presentation, we are going to see what is combinational circuits, their definition, and different types of combinational circuits used in digital systems. In combinational circuits, the output depends only on the present input conditions. The output of combinational circuit at any instant of time depends only on the levels present at the input terminals. So the combinational circuits do not use any memory. The previous state of input does not have any effect on the present state or the output of the circuit. The combinational circuit can have an n number of inputs and m number of outputs. And this is the block diagram of a combinational circuit, and the combinational circuit is designed using group of logic gates. It has n inputs and m outputs, and the m outputs depend only on the present condition of all the inputs. There are number of combinational circuits are there. Some important circuits are half adder, full adder, half subtractor, full subtractor, multiplexers, demultiplexers, decoder, and encoder. Now we will see all of these combinational circuits one by one. Half adder is a combinational logic circuit with two inputs and two outputs. It is also known as arithmetic circuit because it is used to binary arithmetic circuit because it is used to perform arithmetic operations using binary bits. Half adder is used to add two binary numbers or two binary variables a and b. It has two outputs, carry and sum. Whenever any one input is high, the sum is high and the carry is 0. And when two inputs are high, the sum will become 0 and the carry is set 1. And this is a logical circuit of half adder with one OR gate and one AND gate. And next is full adder. Full adder is used to add two 1-bit numbers a and b with its carry of a coming from previous operation. So it is used to add 3 binary bits. So this is the block diagram of full adder, and this is its truth table. The truth table represents, that is, whenever a single input is high, the sum is set. When two inputs are high, sum is 0 and carry is 1. And when all the inputs are a, b and carry are 1, then sum is 1 and also the carry is set. And this is a logical diagram of full adder circuit, which is based on the logical expression given here. Half subtractor. It is used to subtract two binary bits. Its outputs are difference and borrow. And when both the inputs are high, the difference is 0 and also borrow is 0. When A is high, then the output difference output is set and borrow is 0. When B is high, difference is 1 and also borrow is also set 1. And this is the logical diagram of half subtractor. Next is a full subtractor. It's a combinational circuit with 3 inputs A, B and C and 2 outputs, difference and borrow, that is denoted by C bar. A is the minuend, B is a subtrahend and C is the borrow produced by the previous stage. And this is a truth table of full subtractor. Actually, the logical expression of full subtractor is A plus B minus C. So according to this expression, the output will be set or reset. And next one is multiplexers. Multiplexer is a digital circuit which selects one of the n input datas and routes it to the output. That is n inputs and one output. The selection of one of the n inputs is done by the selection lines. There are n data inputs, one output, and m is known as number of selection inputs. So the logical expression of a multiplexers are 2 power m is equal to n. And a control input E is called strobe or enable input, which is useful for cascading. And here the block diagram of a general block diagram of a multiplexer. Here these are the input lines and these are selection lines and only one output. And if there are n selection lines, then 2 power n input combinations are possible. And this is a 2:1 multiplexer, that is 2 inputs and 1 output. To select one of these 2 inputs, only one selection line we need. When the selection line is 0, then input 0 is selected, routed through the output. When it is 1, input D1 is selected to the output. Next is a demultiplexer. A demultiplexer performs a reverse operation of a multiplexer. That is, for 2 power m out for a single input, there are 2 power m output lines. The input is routed through any one of the output depending upon the selection lines. And this is the block diagram of demultiplexer. 1:2 demultiplexer. So this is a data input, and for one input there are 2 possible outputs, and this is selection line. When it is 0, the input is routed through this output 0, and when it is 1, the input is routed through the output y1. And next one is decoders. Decoder is also a combinational logic circuit. It has n input and to a maximum m is equal to 2 per n outputs. The decoder is identical to demultiplexer without any data input. It performs operations which are exactly opposite to that of encoders. The block diagram of decoder is there are n input lines and m output lines. There are n input lines and m output lines where m is equal to 2 per n. So for 2 per n combinations, any one of the output is enabled here. Next is this is an example for a decoder known as 2 to 4 line decoder. Here there are 2 inputs, and for 2 inputs there are 4 output lines. For each combination of 2 input lines, any one of the output line is selected. For when inputs are 0 0, output 0 is selected. When inputs are 1 1, output 3 is selected. And this is the logic circuit of the 2 into 4 line decoder, which is obtained by simplifying this truth table using any one of the method, that is using Boolean algebra or any K-map method. So this is a logical circuit of a 2 to 4 line decoder. And next is an encoder. Encoder is a combinational circuit which is designed to perform the inverse operation of decoder. An encoder has n number of input lines and m number of output lines, and for each input it generates a different code at the output. So this is the block diagram of encoder. For n input lines, it generates an output of m bits. So there are number of examples for encoders: priority encoders, decimal to BCD encoders, octal to binary encoders, hexadecimal to binary encoders, which are used in most of the digital systems. So the priority encoder block diagram is given here. It has 4 inputs. That is, the priority is given as 0, 1, 2 and 3, and the output is, there are 2 outputs. When the first input is enabled, a code is generated which is equal to 0, 0, and when input 2 is selected, it generates an output code 0, 1. Like that, for each input line it generates a binary code of 2 bits, and this is the logical circuit of the priority encoder by simplifying the truth table using Boolean expressions. So these are the sum of combinational logic circuits used in digital systems. Thank you.